A fan that sounds rough does not automatically need a new bearing, and a quiet fan does not automatically have a healthy one. The useful question is not simply ball bearing or sleeve bearing. It is whether the bearing architecture, operating duty, inspection evidence, and exact replacement identity still agree. This film builds that decision without guessing from noise, appearance, or a generic service life number. The two architectures manage friction differently. A ball bearing carries load through rolling elements between races, with internal geometry, lubricant, seals or shields, and clearance chosen as a system. A sleeve bearing supports the shaft on a sliding surface and depends on its material, oil reservoir or lubricant supply, fit, alignment, speed, and temperature to maintain a working film. Neither label alone predicts performance in every fan. Duty changes the comparison. Shaft orientation, radial and axial load, starts and stops, speed range, shock, vibration, ambient temperature, airflow cooling, contamination, moisture, and access for service can all change the dominant failure mechanism. Some sleeve systems are excellent in a stable, clean duty, some rolling bearing systems are selected for more demanding loads. The exact fan and motor design decides, not a universal ranking. Lubrication is often the hidden variable. In a sleeve system, loss of the intended film can increase drag, heat, wear, and shaft motion. In a rolling bearing, lubricant condition, contamination, seal integrity, internal clearance, and race or rolling element damage can change vibration and sound. More lubricant is not a universal cure. Mixing products or adding oil to a seal design can create a new problem. Before diagnosing, build a bearing passport. Record the exact fan and motor models, bearing designation, shaft and housing interfaces, orientation, speed and load range, temperature and contamination conditions, lubrication method, seal or shield, service history, and manufacturer limits. Longwall drawings in the source set show different bearing cross-sections and dimensions. A part that looks close is not proven interchangeable. Use 3 evidence channels together. Acoustic evidence includes new tones, rumble, clicking, or speed-dependent change. Thermal evidence is a repeatable temperature trend at a defined location and operating point. Mechanical evidence includes measured play, roughness under an approved stopped inspection, vibration trend, leakage or contamination, and visible rubbing. One symptom is a clue, converging trends make a stronger case. Inspection starts with a verified safe state. Stop the fan, isolate every applicable energy source, follow the site's lockout, tagout and personal protection rules, verify the safe state, wait for zero speed, and account for stored mechanical energy or hot surfaces. Remove guards only under the exact equipment procedure. Never reach into a moving assembly or treat an off command as isolation. Now rule out the neighbors. An imbalanced or dirty impeller, inlet rubbing, a loose mount, distorted guard, damaged shaft, poor alignment, coupling or belt problems, airflow pulsation, and electrical or magnetic motor sources can imitate bearing trouble. Compare the symptom with speed, load, temperature, and location. Correcting the wrong component wastes downtime and may leave the real hazard untouched. The decision has 3 outcomes. Continue with a documented watch interval when the condition is stable and inside exact model limits. Plan replacement when multiple trends deteriorate, clearance or surface condition fails the approved check, or the manufacturer criterion is met. Stop and escalate when the condition changes rapidly, the rotor contacts another part, temperature or vibration exceeds a required limit, identity is uncertain, or safe access cannot be established. Replacement is not a hammer and heat demonstration. Use the exact fan or motor procedure, the correct bearing identity, clean handling, approved puller, press, induction, support, and force path, and the specified fit and retention method. Avoid transmitting installation force through rolling elements or damaging a sleeve surface. Generic temperatures, forces, fits, and tools are deliberately absent because they belong to the exact assembly and qualified technician. After reassembly, restore every cover and guard before authorized commissioning. Compare rotation, current, vibration, sound, temperature trend, and stable operation at documented points with the previous baseline and exact acceptance criteria. A brief free spin or a quieter first minute is not proof of a durable repair. Record the installed identity, method, date, readings, and any unresolved observation for the next inspection. For maintenance and purchasing, the complete path is: identify the architecture, capture the duty, preserve a baseline, combine acoustic, thermal, and mechanical evidence, isolate safely, eliminate neighboring causes, apply the exact replacement criteria, install only by the approved method, and verify the result under guarded operation. Save this checklist. If you need a project-specific bearing and fan review, send the model, duty, environment, history, and measured trends, not just a noise recording.